Let's solve the following problem, which asks us to investigate whether the following alternating series converges. And once we have decided about that, we should also say something about absolute convergence. So the alternating series that we have to consider here is the sum of -1 to the power k multiplied by 1 plus k over k, with k going from 1 to infinity. So this is an alternating series because each term in the series has a different sign than the previous one. We'll start with a negative number, then it will be positive, the next term, the term after that is negative, and so on. The signs keep changing, keep alternating. So what about, I'll start with convergence. So for alternating series, we have seen this test, the alternating series test, which first starts with the vanishing test. So apply the vanishing test. So we always have to start by applying the vanishing test, and that's a good idea in general. When we have an infinite series, whether it's alternating or not, it's good to check whether the general term will satisfy the condition that it should converge to 0 as the indices go to infinity. So we should take the general term and take its limit as k goes to, the index goes to infinity. So let's calculate it. Well, I would like to remind you of the vanishing test. It says that if this general term does not converge to 0, then the series diverges. Okay, so let's look at this expression. Well, what we have here is just -1 to the power k. If we apply the limit comparison test, what we'll have here is the limit of -1 to the power k times the limit of 1 plus k divided by k. Well, the second limit, the limit of 1 plus k divided by k, hopefully you can quickly convince yourselves that it is equal to 1, because you can divide both the numerator and the denominator by k, and you will get 1 over k plus 1 divided by 1, and 1 over k goes to 0, so you have 1 divided by 1, so this is equal to 1. Okay, so unless this goes to 0, the series will fail the vanishing test, and this series is not even convergent, so the limit does not exist. The sequence -1 to the power k is divergent. It does not have a limit because it's jumping between -1 and +1. Okay, so this is not 0, definitely not 0, meaning that the series fails the vanishing test, which means that it is divergent. Okay, so it is not convergent but divergent. And what about absolute convergence? Well, absolute convergence is about the series that we get from this one by taking the absolute value of each term. That would give us, this series 1 plus k divided by k. So if we take the absolute value of each term, that just gives us 1 plus k divided by k, with k going from 1 to infinity. And for this series, the general term, let me call this term bk, will have a limit of, well, you guessed it, 1. So again, that is not 0. So that series fails the vanishing test as well. So this series also fails the vanishing test. i.e., it is divergent. Okay, but of course we shouldn't have done all these calculations, because when a series is divergent, it cannot be absolutely convergent. Okay, because absolute convergence implies convergence. The opposite of this statement would be that divergence implies that it cannot be absolutely convergent. Okay, this is a solution of this problem.